Going to look another proof by induction. We're going to look at a derivative example. So it is given that y is equal to xe to the power ax, where a is a constant. Prove by mathematical induction that for all positive integers n, so for all of this, dny by dx to the power n is equal to a to the power nx plus n a to the power n minus 1, all in brackets, e to the ax. Okay, so of course the first step is the base case. And if this is not making sense, then go watch my other video on induction, where it's an introduction and divisibility proof, and it should start making sense to you from there. So when n is equal to 1, that would be our base case, because positive integers n, 1 is the smallest positive integer. We have d to the 1y by dx to the power 1 is equal to a to the power 1x plus 1 times a to the power 1 minus 1, and then e to the power ax. So all I'm doing is, wherever there is an n, I'm putting a 1 instead, because it's the first case. So we have to find dy by dx first. So dy by dx, what is that equal to? Well, that is equal to the derivative of this. We can just use the product rule, right? So we would have e to the power ax plus ax a to the power ax. And this is equal to e to the power ax 1 plus ax. And is this true to the right? Is this equal to the right hand side? So this is the question mark. So we have shown the left hand side is this, and the right hand side is going to be a to the power 1x, so that's ax plus, and then a to the power 1 minus 1 is just 1 times 1 is 1, so ax plus 1, then e to the power ax. And these are the same, right? Because 1 plus ax or ax plus 1, you can switch the order around, doesn't matter. So true for base case. Okay, so we're good so far. Now, this is the assumption. So assume true for, okay, I'll write that better. I don't know what happened there. Assume true for some n equals k. So we're going to assume that some kth derivative is given by this formula. You can see how useful this actually is if this is true. That means you can find any derivative you want of this. I go find the 50th derivative of this by just putting n equals 50 in this formula. So in our case, the 50th derivative, well, we look at it at the end, if I remember. So assume true for some n equals k. So how would I do this? Well, we just know where it is, right? So instead of n, we put a k in there. So we have dky by dx to the power k is equal to, this just means the kth derivative, is equal to, well, a to the power kx plus k a to the power k minus 1 e to the power ax. So wherever there's an n, I'm putting a k in there instead. Okay, so show true for n equals k plus 1. Now this is of course the difficult part. Show true for n equals k plus 1. So when n is equal to k plus 1, we have dk plus 1 y over dx k plus 1, which is actually equal to d dx of dky by dx to the power k. So what we're actually going to do is we're going to take the derivative of this thing right here. So we're going to do the derivative of, and now I'm going to expand it. I'm going to write it out in full form, because we can use the product rule, but I want to just write it out in full form so it's easy for us to follow along. So we have a to the power kx e to the power ax plus k a to the power k minus 1 e to the power ax. So we have this right here. So we're going to show that this is true. Well, what are we going to get? So this here we get, use the product rule on this, so we get a to the power k e to the power ax plus, we bring the a in front, so we have a times a to the power k x e to the power ax. This is just differentiation so far, plus, and then this whole thing just stays as it is, and we bring the a in front again, so we have a, and then we have k a to the power k minus 1 e to the power ax. Okay, so far so good, and we see e to the ax is common in all of them, so let's bring that out, let's factorize that. So we have e to the power ax, and now what do we have? We have a to the power k plus a to the power k plus 1 x, because remember, we're multiplying a by a to the power k, which becomes a to the power k plus 1, and then plus k times a to the power k minus 1 times a is just going to be a to the power k. Okay, so far so good, nothing wrong so far. Now what do we do? Okay, I want to put this as the first term, so I want to put it as e to the power ax, and I want to have a to the power k plus 1x over here, plus, now what do I do? Okay, I want to do it like this. I want to factorize a to the power k. So I'm going to have 1 plus, and then k right here. So all I've done so far is just factorizing. I'm just factorizing in different ways because I want to get it in a way that makes sense to me. And actually, this is the final way we need to write it in. So I'm going to write it like this. I'm going to write it in a way, and you will see why I'm putting these extra brackets. So I'm going to write it as a to the power brackets k plus 1 x plus, and I'm going to bring this in front. And I'm going to write this as k plus 1. And then a to the power, I'm going to write it in a different way, okay? I'm going to write it as k plus 1 minus 1. And I'm going to explain to you why I'm doing this, or you can think about it. So this is still the same as this, right? We have e to the power ax, we have e to the power a, we have a to the power k plus 1x plus k plus 1 a to the power k plus 1 minus 1 is a to the power k, which is what we have here. Now look at this and look at this right here. Look at this. We have e to the power ax as usual. Instead of n, what do we have over here? We have a k plus 1. Instead of an n over here, what do we have? We have a k plus 1. Okay, so far so good. Instead of a n here, forget the minus 1. Instead of the n here, we have a k plus 1, and then the minus 1 as usual. So what is this saying? This is saying that it's true. So it's true. Oh my god, I messed that up. So it's true for n equals k plus 1, because that's exactly what we've just shown. We have shown that, okay, we're assuming that it's true for n equals k, and now we've shown that, okay, when actually you take the derivative of that, it's actually true for n equals k plus 1 as well. You just put a k plus 1 in there instead, and it still holds. So if it's true for n equals k plus 1, well, that's it. Then, by induction, this is going to be true for all positive integers n. And what is this telling me? Well, this is telling me that, let's say I want to take the 50th derivative, right? So I want to find, I'm going to do it over here. I want to find d50 of y by dx to the power 50. I want to take the 50th derivative of x e to the ax. How do I do that? Well, that is just going to be, I just put 50 in here. So I'm going to have a to the power 50 times x plus 50 a to the power 49 plus 50 a to the power 49, and then I'm going to have e to the 50, I'm going to have e to the ax right there. That's it. So a could be anything I want. If I had y is equal to x e to the power 6x, well, now I know what the 50 derivative of that is. That's going to, so d50 of y by dx to the power 50 is going to be, well, we just put, instead of a, we put our number 6, and instead of n, we put 50. So we have 6 to the power 50 times x. So that's going to be a big number, and that makes sense. Obviously, it's going to be a very big number because we're taking the 50 derivative plus 50 times 6 to the power 49 times e to the power 6x. And that's it. That's the 50th derivative of x e to the ax. See, look at how useful induction is. Now, once we have shown that we can actually use this formula, well, we're not talking about how we got to this formula. Someone gave us this formula. We're showing that it's true, and then now I've shown you why it can be so useful. So again, state the base case, show that it's true for that. Assume that it's true for some random integer n equals k. Show that it's true for n equals k plus 1, and in our case we have to take the derivative of this thing right here. And we saw that once we rearrange it in a certain way, we get k plus 1 instead of where n should be. And that's exactly what we want to see. And then by induction, that's true for all positive integers n. And then we saw that this helps us doing that. So yeah, I hope that made sense to you. If it did, please like, share, comment, subscribe, and let me know what else you want to see in future videos. Thank you for watching.